Both subjects are going to be in the house. She's trying to get them separated as we can. He's wearing my residence ready.
Good.
Same raw chicken smell. I always cleaned it well, hot water, soap, even bleach. But I found out wood cutting boards absorb juices like a sponge, trapping bacteria like E. coli and salmonella deep inside, where bleach can't even reach. I felt sick. I threw it out on the spot. Thankfully, my husband recovered. But I knew we needed a safer option. A few weeks later, we were having dinner at my husband's boss's house. His wife was using this sleek silver cutting board.
And it's worth pointing out you can add any type of USB device like that, including a printer. And any device you've added a filter for will automatically be picked up the next time you use the virtual machine. As we've now seen, installing a VirtualBox Windows virtual machine As we've now seen, installing VirtualBox Windows virtual machine down to OBS Studio. I just want to point out that in some distros, the installation of VirtualBox is not quite as straightforward as it's been for example, here in Ubuntu, if we search for the can be installed for free. And just to be clear, if you have Intel or AMD graphics, the best drivers will already be installed. But here for NVIDIA, just click on those down, the driver manager, and there we are. We can see VirtualBox Windows experience. I'll admit that it's proprietary and it's running this window on the screen as you can see, but we could go to view and full screen, at which point VirtualBox kindly tells us we can get back to a Windows mode at any time by pressing the host key plus F, with the host key currently set to the
towards that back corner. Once the bill's inserted. I think it is.
Alright. I just said the 932 was the stuck dollar bill. Also, that's the one that that's why I got confused.
Okay, and then 915, I got that one going. I had an entry block.
10-4, Corpus, go ahead.
Please be advised, I'm being advised the correct address is 2421 Avenue C.
I go to the product tree, so we'll just say that down there. And I want to install Windows 11 Pro, and I also want to make sure that offline when we do this, so I can set
to those criminals, because they are so having to do with all of the things we're talking about today with violence. But if anything, I think this Justice Department has been so respectful of the law, because the other Justice Department, with Rita or Lisa and all of that scum, real scum, what they did to the political opponent of a guy that has a seriously low IQ.
Now, I think it's going to be that house where we've gone for welfare checks with the elderly male.
10-4, it's going to be Dino Ortega's residence.
And again, Republicans, President Trump, understand
how difficult this healthcare issue is. They know what it cost them in 2018. My understanding is that the White House wants to see a deal. I know they haven't been explicit about that, but I think they're quietly rooting for these members in the House that have taken matters into their own hands with these discharge petitions to hope that this issue gets addressed in some kind of meaningful way so that it does not continue being a major topic.
3961, 3562.
On the scale and with any sort of services, I mean, you don't get that done for less than $2 million a year, what we were looking at.
I'm looking, when I'm driving downtown or driving uptown, there's a lot of homeless people in front of businesses camping out. What's the story behind the bridge on Crosstown where they used to be at and then they fenced it?
2801, 1044. 25, 2014, 7 Green. Caitlin, March, Corpus Christi, confirmed 27 things, subject Corpus Christi, Class D, restriction 8 Adams, 2031, 29.
10-4.
10-4.
But the worst was yet to come.
Cost them in 2018. My understanding is that the White House wants to see a deal. I know they haven't been explicit about that, but I think they're quietly rooting for these workers in the House that have taken matters into their own hands with these petitions to hope that this issue gets addressed in some kind of meaningful way so that it does not continue being a major
Just to show you what I've got here. This is a test copy of Windows 7, and here I've installed
suppressing the Biden laptop story during the 2024 election.
Off the top of my memory, sir, I believe the FBI was in possession of verified information on that laptop, and it was improperly publicized that they did not have information.
And do you need EMS?
He declined EMS at this time.
Yeah.
Alert. Malformed file moved to quarantine.
Santa ever get mad?
Will Santa ever get mad if we don't leave him out any cookies?
I think he won't get mad, but I think he'll be very disappointed. You know, he tends to be a little bit on the cherubic side. You know what cherubic is? I think Santa would like some cookies. You'd like to.
Overnight 30, minute 30. For chest band data to Hancock, Unit 1. Yes, 130. Auto fire dispatch. 2036.
Biscayne, one female 95. Ten for 215.
Not able to card once the bill's inserted.
I just put the 932 with the $12 bill also on the, that's why I got confused.
Yeah.
At least
So 129, 125, K19. Is this for booking? Or complaint booking? Give me first.
So far.
155.
Silence trimming complete.
Reckless driver, Wildcat and Buddy Gamma, listed.
Some stuff isn't as smooth as it should be. There are some performance problems when opening and closing apps. Not sure who.
Be transported 95. For 200, beginning mileage 15946, 15946.
Here we are back again. This time with a fully updated system. We haven't got anything indicating on the shield here, and it tells us the system is updated. And if any more updates did become available, we would have a red dot, an indication down here, and we could repeat what we just did.
The program is to install a virtual machine. And here I've installed something called Virtual Box, which is running down here. And this allows you to run a guest operating system inside the host, the main operating system.
I'm going to leave the call working.
Once again, I've got a video called How to Set Up a Virtual Machine that takes you through this. But just to show you what I've got going on here, down here I've got a copy of Windows 7 running. This is a test copy of Windows 7, and here I've installed, I think it's Office XP, early.
And then 915, I got that one going. I had an entry box.
10 for him, sir.
Oh, by God, you'll never leave this.
Yeah.
Who is Buffalo Bill? His first name is Louis. Much of the rest of the cemetery south, but down in Tennessee. And I have a few conditions of my own.
Clean him up and get him ready to go. Desktop, it is still a first draft. The applications are available. The settings are very simple.
At the time,
and you can clearly see that some stuff is not animated as it should be. Some stuff isn't as smooth as it should be. There are some performance problems when opening and closing apps. Not sure if it's...
When you get a chance, sir, can I have you check 37 and 77 on the interchange northbound? 37 and 77 interchange northbound for road hazard. RP stating there's a tire and a rim in the middle of the roadway.
Yeah, or is it going to be on 37 or on 77?
Mel stated it was right at the interchange. Possibly when you're taking the exit.
64.
64.
I'll take that call. I'll be around.
Say something there?
Renaming and preparation complete.
611. This is Ted Jones for Paul Phillips. Thanks for watching. See you next week for more King of 2 Miles.
I serve my country, and now I carry legally everywhere I go. Here's how. National Concealed Carry my country, and now I carry legally everywhere I go. Yourself a valid CCPD.
I fucking hate God, my boot.
I'm showing that that is a Hilton plate, Tier 24 Chevy pickup, registered to a ship out of
PO1. And once again, we're arriving in the Mint, this time installed and executed. So I'll just not here. And here we are back on the desktop with wizards, and there's various things that can be done.
Our database sorting complete. The entire audio workflow is finished. New files sorted. 0 placed in worded folders. Quarantined 1 empty folders. LVC JSON generation complete with worded series files. Workflow complete with fixed JSON.
access. Halloween fireworks.
Rush.
I'm finna you kill.
Given the 915, I got that one going. I had an entry box.
Okay, farm, sir.
Covenant 999 assault injuries, 3302 uppers, 3302
Yeah.
5002. Repeating, full fire dispatch, 2256.
Yeah, whatever. Well, shit, play another recording, computer.
It was definitely a real step up from the match law, creating a spark, and igniting another very interesting. It was definitely a step up from the match law, the break. The problem with it was it was back to the mechanism.
Registered to Adam Driver House.
Early days about when they didn't have the modern machinery. So again, you can tell in the early days is when they didn't have modern machinery, it was
What you want to do is save hundreds from the green.
Keep your fucking mailbox list of phone numbers and that over. It's true.
If you got any youth go out here, they're probably 18.
In urban households, we're talking about areas that don't have times, and what it allows local government to do is offer SNAP to people who can't find jobs because there aren't jobs in their area. And this makes it more difficult for people to stay on SNAP who need to stay on SNAP because there just isn't the opportunity in their part of the country. And that's an important thing to realize when we talk about SNAP, because the way that it's often framed is people not wanting to work, and the reality is there aren't these great jobs out there.
This country's ABS has some communications. The following is a flight question checkpoint.
Yeah, somehow I'm
Yeah,
contacted.
you feel.
Well, I guess I'll turn the live stream to private so you can't fucking listen to it on your phone and drive around fucking my neighborhood like a
Lex 1,
vulture.
Lex 1, Lex 1.
People to extract lead this way and expose themselves knowingly to this toxin. How do the people feel about it? Do they want to see change? I'm sure they don't want to see these factories and these economic opportunities go away.
They definitely want to see change. I mean, people are eager to see this pollution minimized. They want to see equipment that comes in that limits the lead pollution that's reaching their communities, the sort of stuff that we have in our own communities here.
7-1.
Has our suspension for a crash and I'll 27 on Escamilla View.
How'd she get a police radio? How'd she got access to a police radio so she can make comments about what my live stream says constantly? The little toy radio repeaters in my neighborhood. Her rate limit has been with a 10-4 workhorse. Yeah, got pneumonia cleanup there and debris for free.
$37.77
That's
to
what they call
interchange.
$150,000 catamarans, tools and equipment for your business. Everybody's like lumber, building material.
Starting JSON security scan.
Leaders in debris. Fucking whole city.
Find a number of packages available, of which we need to install
Fake
3.
dispatch radio code
And
bullshit.
the first of these is the base package, so let's just install this. This gives us the basis of VirtualBox. Of course I need to enter my password.
Please complete my call at 4002.
There we are, now installed. So we go back. We're next going to install VirtualBox Guest Editions ISO, which will improve the performance of our virtual machine, not least by permitting it to run full screen.
Hey, fuck you. Fucking computer. I guess I'll microwave some hot dogs.
So I'm on 631. What was the crossroad where that green vehicle was located at?
631 and 188. I can go ahead.
Thinking about what I think of her as? Yeah.
Everything good? Available for. Going to be from the Hatch RV Park. Is where PD's with the victim.
Warning. Large file detected.
There's a lot of 10-4 workhorse recordings, apparently. Fuck, I'm tired of hearing it. Play something else.
There's going to be a warning out of service condition.
That mother, was he gay? Now this computer figured this shit out. Well, I'm a straight, heterosexual male. Who's this? We got some pig snort action out there. Pig is what's for dinner because it's cheaper. Why in the hell they did all that? They're going to the same.
So we'll click on finish.
President Trump has been very vocal that he disagrees
And
with
here
the
we
fact
are
he wants
back
lower
again.
rates.
I need to log
Today's
in.
Chair Powell says not so fast, but
There we go. And nothing looks different, but now with guest additions installed, I can right click and go to
we will
display.
very much see a different makeup at the Fed depending on who the president chooses, and that could mean that there is likely even more division potentially next year.
Elizabeth shows our thanks to you. We're seeing dramatically.
That was the one before that you kind of cut off.
Yeah, Terminator off. Shackle, 49 Shackle Street, easy of 1005. EMS 1 at 2221.
Terminator off.
Block off.
Log off.
3664 UTL today.
Log off. Log on.
So we'll
Been very vocal that he disagrees
and
with
here
the
we
fact
are
he wants
back
lower
again.
rates.
I need to log
Today's
in.
Chair Powell says not so fast, but
There we go. And nothing looks different, but now with guest additions installed, I can right click and go to
we will
display.
very much see a different makeup at the Fed depending on who the president chooses, and that could mean that there is likely even more division potentially next year.
Elizabeth shows our thanks to you. We're seeing dramatically.
That was the one before that you kind of cut off.
Scan complete. System is secure.
Not want to respond here. Open line.
traffic. Go ahead.
B10-6 out of county, 76 to 642.
All of which have different desktops. And here, the most popular is the Cinnamon Edition, which is the one we'll mainly focus on in this video. So, let's click on Download, and if we go down this page, we find there are loads and loads of mirror sites that actually provide access to the ISO file. I'm in the UK, so I'm going all the way down to UK, there we are, and I'm going to download from the University of Kent Mirror Service. And so I'll click to save the ISO file, which is 2.7.
Cancel calling for a K-run since he gave consent.
Well, hell. What else you don't know, computer?
Well, hell, I don't, you know, it's like showering.
505, friends, radio check.
Storm, rainstorm. You know, you flush the toilet.
What's this picture mean?
I'm surprised water's still coming.
Get mad.
Like, one thing on so you get a little bit of water out of it.
I think he won't get mad, but I think he'll be very disappointed. You know, Santa's, he tends to be a little bit on the cherubic side. You know what cherubic is?
Radio check.
You'd like to...
The water barrier in front, like this. No fluorescence. If I start this up first, and then block it,
Talk about phone surveillance by
you see that the energy.
we get direct evidence of how
Keep going.
today, that's going to change.
Deal for David Vizcano is showing expired in 2023. Shows he's licensed
I'm just
in
a
another
recording
state
machine.
Other than that, he's clear. No, he's coming back to William Jones, AM 6918, expiring March 26th.
I'm just recording it.
So Mark Mass down here.
Why is your recording in for asking you what radio?
Dumpster fire 602 Morgan at Around Rebellia.
My name is
Video recording equipment inside the house.
Go fire dispatch 2312.
What else you got for me, computer?
And it's an LTS or long-term support release.
Right now,
We got our train away.
run this, it will
Requirements
to be the most.
along with a minimum of 2 gigabytes of RAM, although 4 gigabytes is recommended. And so, in practice, Linux
that goes by, I feel more and more confident.
When Rivers first joined the NFL in 2004, Patrick
Hey, we're back at
Mahomes' Friends had just aired its finale. Mark Zuckerberg launched an online experiment called Facebook.
When in 2025, they're often the least important purpose of settings. Because what actually makes you practical usually has nothing to do with your IP address, your browser, your behavior.
Okay, any requests from the public? A topic of public comment?
Here we're going to do a search for that. And I'm now going to click on Fonts Ubuntu Classic and go to Package and Lock Version. And oh look, it turns red. And just to be safe, I'm also going to do the same thing to Fonts Ubuntu. There we are. We should now have permanently installed the old, the thicker Ubuntu fonts.
They definitely lag.
action menus, which is rather cool. If we want to install a new application, we can go to the graphical software manager, which is here, and which comes up more quickly in Linux Mint 22. And it's important to note that whilst Linux Mint 22 is based on Ubuntu, it doesn't use Canonical's Snap application format, which some people dislike. And for this reason, the version of the Thunderbird email client here in the Linux Mint 22 is a dev version.
Yo one.
Yo one. Hello?
Outside is best competency. 664. Progress is 37 southbound by the Texas Star. It's going to be a black Buick Envision. Make contact with Peter.
Generation.
Let's go.
Easy, I appreciate it as much.
Let's go over there.
3-0. Can you show me a ride at 7041 Fruitwood Drive? 10-4.
I'm good.
Hey, I don't know if he has a radio on, but we're in line right now. Towards the front.
Like it live in chapter 5. Yeah, it could have been Trump Rolls-Royce jet engines.
Yes, sir. I have another call. One person calling at 213 East 7771. Molester called in advising that his fiancée, Donna Lester's phone is pinging at that address.
I don't have a product key, so we'll
but she's not answering. He did make location, spoke with the homeowner, George Hernandez, asking if she was there.
I also want to make sure.
10 for apartment 109. 76.
Yeah, they'll have to find somebody else for all that.
Yeah. She had an individual who were getting off the unit and spit at her.
There's many Manchurian candidates that are in the United States. Just find somebody else to do what they want. Just saying.
Does the object in this photo look familiar to you? Possibly take you back to college physics class? Dr. John Shive, host of this next film, invented it at Bell Labs in the 1950s. It's called the Shive Wave Generator. Object in this photo look familiar to you? Possibly take you back to college physics class? Dr. John Shive, host of this next film, invented it at Bell Labs in the 1950s. It's called the Shive Wave Generator.
Is the base package, so let's just install this. This gives us the basis of VirtualBox. Of course, I need to enter my password.
That's now installed. So if we go back, the next bit of install, VirtualBox Guest Editions ISO, which will improve the performance of our virtual machine, not least by permitting it to run full screen and allowing a shared.
Charlie 42 copy, Paul Lincoln, 0284.
10-4. 1 mile, starting over 9.
Please contact us and provide that information. At this moment, I do want to say and share that my profound thanks and appreciation for all of the first responders who have come to assist us and all that are gathered right now speaking to continue this investigation, to include all of the City of Providence resources, state resources, and the federal government in terms of the FBI and ATF.
And if you have a preferred app, you can install it through Flash.
Now,
we also have a very basic text editor. It doesn't do much. It does have some Git management features if you need that, but I think most people will just use another text editor if they need to edit files in a Git repo. It's a very simple one, but it has the merit of existing and letting you
Roger that. Thank you very much, sir. Appreciate the call.
The bill validator spinning round and round and not able to give out cards once the bill's inserted.
Alright, I just took the 932 with the $12 bill off. That's why I got confused.
Alright, just a second. Okay, and then 915, I got
at least.
Thank you, ma'am.
Yeah, but the FBI says it's evidence.
Significant over the year one of our operation. No, that's good. Yeah, I was just wondering. When I was looking at so it's Q3. You compared Q3 for each one. Correct. Okay. In relationship to December, is December because of the holidays and the ice rays and everything that's going on? Is that usually a pretty robust month?
It
usually is a pretty busy month for us, especially with a lot of the holiday parties that we do.
You're right.
Route 15 is 1044. 8203030, Bracelet Drive, Pursuit Glen Harbor, Woodhaven. Stay Christine safe. Walk off of EMS 1, EMS 1 at 2051.
A yawn raised the GP level.
If you got any years to go out here, they're probably 18.
Sure.
Hello.
Hey, Frank.
I guess so.
PO1.
I love what they've done. It is a fantastic first draft of a desktop. It is still a first draft. The applications of their homes, the settings are very bare bones, and you can clearly see that some stuff is not animated as it should be, some stuff isn't as smooth as it should be. There are some performance problems when opening and closing apps. Not sure if it's
277 Trevor.
Bluetooth shield active. Monitoring for blue port. Alert. Blue jacking overflow detect.
Hello.
Hey, Frank.
I guess so.
PO1.
Hey, yo, one. Hello.
Hey, Frank.
They went back to generic recordings. TV.
So I was sat watching TV the other day, and because it's coming up to Christmas time, the film Alien was on. Don't ask me why. But anyway, if you've seen that film, you'll know they have this pretty cool little motion detector so they can see when the alien's going to appear, even though they can't see it coming. And that got me thinking, can we actually build something like that using an ESP32? It feels like it should be simple, but actually after some...
Alien movie. Instead of calling me an asshole. Because this is a microwave UHF induction recording machine. Did I mention it? Screws up microwave UHF. Printing. Didn't I mention it's probably Texas Syndicate? That Texas Syndicate bitches have been coming here trying to kill us for a while. Well, don't send Texas Syndicate to transport your shit. I don't have a problem with it.
It's not private, and it never was. The message looks secure.
Texas Syndicates don't need to be...
in companionship, laughter, and deep devotion. In his final words, Gil urged us all to chase what thrills us and to love fiercely. Gil derived his slave. He lived like one. And now, someone else he loved so much. Farewell, Buck Rogers. Thank you for the wonder, the warmth, and the timeless adventure.
Sure, 28
There are some performance problems with opening and closing apps. Not sure if it's opening and closing apps. Not sure if it's
49 warning. 49.
As a follow-up visit to confirm that previously cited violations have been corrected and the establishment is back in compliance. Again, we provide the service on regular basis here. Currently our fee is $50. State allows us to charge up to $200.
The DA confirming he used a knife to allegedly kill his parents. Nick Ryan is expected to appear in court today, but his movement has not yet been medically cleared by the jail. And we have new reporting tonight on Nick and his complicated relationship with his parents. Morgan Chesky starts us off tonight at the courthouse in Los Angeles.
These are some of the most serious charges that a DA's office can bring.
I already knew that. I'm a super villain when I watch activity on TV.
Again, not a great deal. Image viewer, LibreOffice Draw, photos. We don't here have GIMP, the GNU image manipulation program. Used to be included. Apparently, user feedback said people didn't want that pre-installed. You can obviously add it yourself. Under Internet, again, it's pretty minimal. We've got the Firefox web browser. We've got Lumina for connecting to remote desktops. We've got Office, which includes LibreOffice. You'd probably have guessed that.
Roger that. Thank you very much, sir. Appreciate the call.
Sitting around and really not able to give out cards.
Well, you got any youth go out here? They're probably 18.
I just took the 932 with the
Back at Farcops.
That's why I got confused.
Okay, and then 915, I
The layout. At least.
And then in a pinch, we either staff will go out of pocket.
I believe they were setting up
if we
panel
can squeeze a little
72
bit
for
of
you.
money out onto a P card. I just set procurement on fire, but then we'll go and
that's what I want to try to avoid, is to try and pre-plan for some of this stuff.
And we do pre-plan for it. We know that we have to have a box of miscellaneous pairs of sweatpants. We have to have feminine hygiene products, and we have to have adult incontinent items. We have.
The machine.
Back at Farcops.
Motorcycle. Being followed. Dynamite cam turned on. Emotion light. Dynamark.
Oh, 3100.
He's the end of the world.
I thought David said to go to the plant. Radio check laboratory.
You told me to tell her when you're in the rest of the column, I guess.
What about 3D printing? You got bed leveling or anything in there? 3D printing. Slicers, stuff like that. Why are the cops
There are 3 meters that are about 10 feet from there to there. They're all on wooden posts. There's dual polarization. And this is all steered by electronic phasing. So even back in the 50s, one knew that you could do this. In Europe, we will have another geospace remote sensing radar that's about that size, but with fully electronic steering down to the element level. 1,432 phase dipoles at 50 megahertz or 60.
I don't know.
So we'll click on finish.
President Trump has been very vocal that he disagrees
And
with
here
the
we
fact
are
he wants
back
lower
again.
rates.
I need to log
Today,
in.
Chair Powell says not so fast, but
There we go. And nothing looks different, but now when Guest Edition is installed, I can right click and go to display.
$9898 to get a free info kit on gold IRAs from Birch Gold, which is the only gold IRA company out there.
We're seeing there was the one before that you kind of cut off. I don't have root tax. She's been taken already. She's gone. That's it. She's gone. I'm already
Yeah, that's
proceeding with
smart.
my own taxes.
Dynamite security too, huh? Got Dynamite security next door on the other side.
It puts everything in one place with clear categories. Another key feature is KDE Connect, a tool that lets you connect your Android smartphone to your Kubuntu system. With KDE Connect, you can share files instantly, see notifications on the desktop,
Guest Edition ISO, which will improve the performance of our virtual machine, not least by permitting it to run full screen as shared.
$13.91 for nominal paying, ESC 1315, be at 542 Rosemary Street, or about fire dispatch at 2337.
Sound like they're punching something in their phone.
Point for an 18-month-old child that has fallen off of bed. Nurse reported that he's not physically moving. He did stop breathing for a short time. He is currently breathing at this time.
Yes, sir. See if you can clear frequency for emergency message. Is there a frequency for emergency message on our inspection?
Oh, I doubt Alex Trancris is going to come all the way from Puerto Rico, where the fuck he ended up to come execute me for mentioning his name. These are 2 bitches next door that ain't there.
In the morning it looks like it goes through and then like that some early evening like this. No, it's like this. And then by the end of the day it's going back to that directory and list. But of course if you want you can pick a desktop wallpaper and we can copy lots of files. You can probably tell straight away looking at Go OS it's a very stylish operating system. Let's bring up for example the file manager. I like the look and feel here. It's a nice system to use. It's very calm. It's very reassuring operating spell it and also Wales. And what that's going to do
Traffic.
Usually
2728.
With your IP address,
23.
your browser, your behavior.
Okay, any requests from the public to make public comment on any items 9 through 28, please come forward.
Guajardo can do comments about Johnny Heath and 529 Clifford Street. How about that shit?
Helicopters in the air. We can't forget that 2 students lost their lives today in that classroom doing what so many of us and so many of our kids have done, taking a final exam to end the semester and head home. Our team of Christi is my colleague John Paris, who's just a couple of blocks from where I am, but closer to the scene.
The year is 2012 and 3D printing is beginning to hit the mainstream hard. For the first time ever, fully functional printers and not just kits were becoming readily available from the likes of Ultimaker, Lulzbot.
Hey, robot with a saw on it.
This is my 30-pound combat robot, the hash-slinging slasher. It's one of the most complex combat robot builds I've ever done, using a nifty combination lifter and devastating articulated circular saw. In this video, I'll show you how I designed and built it, and how it fared against Australia's best combat robots. This video was made possible by PCBWay. More on that. The year is 2012 and 3D printing is beginning to hit the mainstream hard. For the first time ever, fully functional printers and not just kits were becoming readily available from the likes of Ultimaker, Lulzbot and MakerBot at a fairly affordable price. You see, although 3D printing has existed since the 80s, it was locked down behind corporate patents. Instead, the entire consumer 3D printing market we know today owes its success to Adrian Boyer and the RepRap community, who poured their collective resources together to create open source designs, electronics, firmware.
Today we're going to try 3D printing a machine part out of carbon fiber reinforced nylon. Is it really a viable replacement for aluminum in the shop? Let's find out. Welcome back to Cloud 42, I'm James. If you've followed the channel for a while, and in particular if you've followed my lathe electronic lead screw project, then you know I still have the servo motor hanging out of the front of my lathe on the temporary bracket that was just there for prototyping. I think it's high time we got that thing in the back where it belongs, and to do that we need to make a motor mount. Now, I normally would just grab a piece of aluminum bar, design something up in CAD, take it over to the CNC mill and hog it out. But today I'd like to try something a little bit different that's a little bit less labor intensive. This is a 3D printing filament called Nylon X. This came from Matter Hackers, and I believe Nylon X is their brand name. This is their version of a carbon fiber filled nylon 3D printing filament. The nylon in this is PA12, and it's filled with 20% by weight chopped carbon fiber. Carbon fiber adds strength, it adds stiffness or rigidity to the parts. Nylon tends to be fairly flexible, and the carbon fiber makes the parts more rigid. Helps with impact resistance, but it also helps with thermal shrinkage. So, as we all know, when you're 3D printing things like ABS, the parts actually shrink as they're printed and as the plastic cools, and that tends to pull them off the bed, which is why it's so hard to deal with bedding with ABS. Nylon has the same problem, but in theory, the carbon fiber fill helps to reduce that shrinkage and helps to make it easier to print. Still, bed fusion with this stuff is a challenge, and from everything that I've read, the best bed surface to use with this is either glass with the right kind of glue stick or Garolite. And so I actually bought a sheet Garolite, put it on my printer bed, and we will try that. In theory, you want a bed temperature up around 70 to 80 degrees Celsius, but I've read of people online having success even with a completely unheated bed, though that's not generally recommended. The material prints at a relatively high temperature. This stuff, 250 to 260 degrees Celsius, which if you've printed fast with ABS is not unusual. But other brands of carbon fiber, nylon, and nylons in general can print at even higher temperatures, up to 270, 280, or even higher. And so you definitely need an all-metal hot end to print this stuff. The other thing to know going into it is that this stuff is very, very abrasive. The carbon fiber filaments in it will just chew up a brass nozzle. So you definitely need a hardened steel or stainless nozzle on your printer. I looked up a couple of hardened tool steel nozzles, and we will see how that works. This is commonly referred to as black aluminum because it is useful, in theory, for making parts that you would normally make out of aluminum. The tensile strength isn't as high as aluminum, the rigidity isn't as high as aluminum, but for a lot of applications, from what I'm reading, it should be good enough. So let's go design up a 3D printed motor bracket and see if we can get this stuff to print. This is Fusion 360, but the stuff I'm going to show here will apply to pretty much any CAD package. I've already modeled up a motor mount, and you can see I've got a register here and a hole for the motor shaft and 4 threaded holes for the screws, and these are sized for the NEMA 23 size motor package. And then on the other end, I've got a couple of 1/4-inch slots here for mounting screws that will give us some adjustability. And let me just show how I modeled this. I'm not going to go through all the steps. I basically just started with a sketch with the plan. So the overall size is 2.3 inches square for the motor mount, and then I added 2 more inches. So this is 4.3 by 2.3 inches. And I just sketched out the hole I wanted, the size of the register, the size of the slots, and I put in points for the screw locations. And so then I just extruded that up 1/4 inch, and then used the fillet to round the corners. Then came back and used this sketch, turned it back on, and used these points with the hole tool to actually create holes the right size for 1032 screws, and these are tapping size for 1032. Went ahead and extruded, using the same sketch, a pocket here for the motor register, and then came back with the create thread tool, selected all those holes, and put in threads. And these threads are 1032 UNF, and I marked them as modeled so that it actually put the 3D model of the hole into the part, and you can see that that's there. Ideally, with a perfect 3D printer with infinite resolution, this will result in a threaded hole that you can actually put a screw in. And in some materials you can make that work. My understanding is that Nylon X tends to shrink inside holes a little bit, so I'll probably end up running a tap through those. Then the last feature here are chamfers on all of the edges, top and bottom. I did leave them out of the motor register because I want that sharp, but especially every corner surface, except the threads, that touches the bed, I want a chamfer on that. It does a couple of things. It kind of prevents the swelling or elephant's foot that can sometimes happen with the bottom layers. And the other thing it does is give you a place to pry or to edge a spatula or a knife underneath the print if it gets really stuck to the bed. So I think that's it. It's a real simple design. Let's send this to Simplify 3D and print it. Now, Simplify 3D has recognized that I modeled it in inches and wants to know if I want to convert it and scale it for millimeters, and yes I do, because in this case I did model the part using inches because I started with the NEMA 23 motor size, which is specified in inches, specifically 2.3 inches, hence NEMA 23. But the 3D printer works with millimeters, so it has to convert it. So let me hit Control L, and this allows me in Simplify 3D to select any polygon in the part and orient that down to the bed. Click Center and Arrange, and we should be about ready to print. Let's go look at the process settings. Now, this is the first time I've ever printed anything with Nylon X, so I'm just working with parameters that I found on the Matter Hackers website and other kind of forum posts with people who have worked with it. So I'm printing it in the left extruder. I've got a 0.4 millimeter nozzle. And for retraction, this stuff does ooze quite a bit. I went ahead and set it to 2 millimeters. We'll see how that works. Layer height, I'm going to print 0.25 millimeters. I have always printed everything at 0.2 millimeters, and I finally realized that I can print at 0.25 or 0.28 or 0.3, and the prints go a lot faster, and most of the time I don't need that resolution. So I kind of settled on 0.25 millimeter as my standard layer height. And first layer height usually has to be adjusted for different materials. For ABS, I set this a little lower to get a good squish into the bed. For PETG, it's a little bit higher. I'm not really sure what I need for the nylon, so we'll start out at 100% and we can try adjusting that later. This is simple, so I don't need a skirt and brim or raft or anything like that. For infill, we're going to run about 40%. That's probably a little high. But and it'll make the part a little stronger. It's probably not going to have a huge difference on the cost for a part this size. Don't need any support. For temperatures, I'm going to run the bed at 60 degrees Celsius. I've seen recommendations anywhere from 0 to, or room temperature, all the way up to 80. Let's start around 60, see how well it sticks, and adjust from there. And I'm going to run the extruder at 260. That's kind of near the high end of the range, but on my printer, I found, especially with ABS, I have to run way up at the high end of the range to get good layer adhesion, so I don't know if that says anything about the temperature control on my hot ends, but we'll start at the high end and see what happens. Cooling doesn't matter, I actually have the fan unplugged. Now, the G-code has this set of global G-code offsets, and I think most slicers have this. And you can use the Z-axis here to sort of raise the print off the bed if the adhesion is too great, or lower it if you need the print closer. I generally don't use this. I generally use the first layer height. The difference is that this will raise the whole print up without adding any other plastic, where raising the first layer height above 100% will add extra plastic to fill that space. It also will keep track of the resulting height of the part. So if you just raise the Z-axis here, your part will probably end up being a little bit taller because it doesn't take into account the fact it's just printing it above the bed. It doesn't know that it's printing it thicker. For speeds, I'm going to run 3,000 millimeters a minute, which is about 50 millimeters per second. In theory, you should be able to run this stuff anywhere from 15, they say, to 60. Other people say 100. I print most things at 100, but we'll start at half that for now. And I think that's all. I think this is a good set of settings. Let's give them a try. I'll take a look here and make sure that everything looks sane. Lay down first 3 closed layers, then we start filling in with the support. We've capped off the register there, and it's going to go up and cap off the top of the part. I think it's interesting to look at how the threads end up being rendered. If you watch as we go up through the layers, it's basically printing an oblong hole that it's moving around to kind of approximate the threads. So for something as fine as 1032, it's not going to be perfect, but it's a starting point. So let's send this to the printer and see what we get. I have my 3D printer outfitted with a Garolite bed. Garolite's a composite material. It's a woven either fiberglass or linen. I'm not sure. I've seen it referred to as both, but it's similar to PC board material. It's an epoxy impregnated fiber board, and this, from what I've read, is really the ideal material to print nylon X and other nylon and other high temperature filaments on. You can also print on bare glass with a PVA glue stick. I haven't tried that. This is the only surface I've tried. I went ahead and just got what was recommended. The other thing that I've done to this printer for success here is I have replaced the nozzles. I took out the brass nozzles and put in hardened steel nozzles because the filament with the carbon fiber in it is so abrasive, it'll just destroy brass nozzles in short order. So I've got hardened tool steel nozzles in there that should prevent that. And I've done a little bit of experimenting to try to figure out how to get the best bed adhesion. And you can see here on the bed, I've got a little mark of shame already where I've pulled some of the surface off with a print. I was doing some test prints on here and got something adhered a little bit too hard because I had the bed a little too hot, and I had the layer height set so the filament was really getting embedded into the surface. I've since raised the nozzles, raised the Z height about 1/10 of a millimeter, and lowered the bed temperature to 40 degrees Celsius, putting the filament, I believe, at 260, and that gave me a pretty decent adhesion to the bed that held the part and didn't allow it to warp during the print, but still allowed me to get it off. So we'll try those settings here. This is a bigger part, and we'll see how it goes. We'll start by wiping down the bed here with 99% isopropyl alcohol. And this is just to make sure there's no skin oil on it from me touching it or dust or anything else that will interfere with bed adhesion. And I think we're ready to start the print. Okay, well that's the print. Let me see if I can get it off. Got safety glasses here. You'll see why in a moment. I have a knife. This is just a snap knife, but I have sharpened the end of it, and I did that for another project at one point, but it's great as long as you don't dig in for getting under the edges of things like this. So let me see if I can work under the edge. And I can hear it cracking.
Speaks for itself. Let me ask by show of hands, if you think that there would ever be a case where it's appropriate...
I don't want to actually snap the knife off. I just want to use it to free it from the bed.
Lindsay, if I may, one way that the federal government influences us all and every administration...
It is pretty tight. Looks like I actually lost a little chunk of the blade there. Let's try with a spatula here.
Food service industry. So specifically, Senate Bill 1008.
I don't see the blade piece, but there is the part. I can see the marks left by the knife, but it's off in one piece. You can see the places where I scratched the bed by doing that, but the actual adhesion maybe pulled a little bit of the surface. I think I'm going to need to reduce the bed adhesion even more for something big like this. But it doesn't look to be warped, so let's take it out in the shop and see if it fits. And here's the finished part. I like the surface texture of it. Along the sides of the print, it's got this kind of matte texture. I know it's black. I know that's really hard to see on camera. But it's got this kind of black surface texture that makes the layer lines really hard to see. They're definitely still there, but it makes it hard to see. The part is very, very light. It's probably about the density of ABS, maybe a little bit less. And just trying to twist it, it does bend. I can bend it, but it's relatively stiff. I actually expected it to be a little bit more rigid than this. I think we'll just have to get it into the final application and see if that is going to work. Now, another thing that I noticed on this is that this register I designed and the slots and the size of the holes, they all came out a little bit small. The outside dimensions are pretty much exactly dead on, but the inside dimensions of the openings are a little bit small. And, you know, I had read that this might be an issue. The filament is just spreading on the inside, or it's stretching around the inside. It's also possible we've got an overall shrinkage. I played around with the measurements for a while, trying to figure out, okay, could I scale it up a little bit and then shrink the wall, which would affect the outside and the inside, and get to the right dimensions. But judging by measuring the center-to-center distance between the holes, I don't think it's a shrinkage issue. I think it's an issue with the edges. For now, I just need a workable part. I will play with this later. So I went ahead and adjusted and printed another one. And this one came out, you know, the sizes are pretty much right on now that I've actually made the adjustments. And so I actually designed it oversized by just doing a push-pull on the surfaces to expand them a little bit, and got it to the size that I want. But again, it doesn't exactly match the model. So I've still got some work to do to figure out the scaling or the adjustment factors of how to get this stuff to print. Feel free, I'm sure you're already doing it, go ahead and put down in the comments about how your printer doesn't have that problem. It prints everything perfectly, and if I would just get a decent printer like yours, then I wouldn't have that problem. And maybe someday I will. Maybe someday I'll be fortunate enough to have a printer like yours. The other thing that I did on this, because this adhered to the bed so strongly, is I lowered the bed temperature on this. And I lowered it all the way down to 30 degrees Celsius. And I don't know if you can see it from the reflection, but at the corners there was a little bit of lifting. In terms of the usability of the part, it's not going to matter at all. But at the very corners, you can see it's rounded a little bit from the reflections there of the lights. So I think I'll be playing around with it. I've tried some other prints in this material, a little bit higher bed temperature, and I think they worked a little bit better. In fact, you'll remember this part that I printed on the resin printer. This is the encoder mount for the electronic lead screw. And I went ahead and printed one of these in Nylon X, and this is a thing of beauty. I mean, just look at that matte surface on the outside, and this thing is strong. It is rigid. It's more rigid even than the resin printed part. And so I am very happy with this, and I will definitely be using the material. Now, there's a little bit of flex in these big plates, but because of the cylindrical surfaces here and the geometry, this ended up being extremely rigid and very, very light. So I'm definitely going to play around with it for parts like this for sure, even if this ends up being a little bit too flexible. Let's talk a moment about cost. They really like this stuff and they're really proud of it. This is a 500 gram roll and it cost me $58. So we're talking about $120 a kilo for this filament. And so with that pricing and the amount of filament in one of these parts is about $2.50. Same thing with this, it's about $2.50. Now, I did some back of the napkin math, and a piece of aluminum flat bar at retail cut prices for a piece to mill this out of, it's about the same price, $2 or $3. So in terms of the actual cost of material, if we're talking about using it to replace a CNC milled aluminum part, the material cost probably about the same, and there's way less labor in this because I can just throw this on the printer and I can go do something else while it prints. But like I said, I am just really, really happy with this. This did require support material, so I just printed the supports up underneath, and I left the top of the supports fairly sparse, didn't do the dense infill, and so the underside of this surface that was supported is really rough. But for this part, it just doesn't work. So I can design appropriately, use support material, and make complex geometries like this out of carbon fiber that should work very well. Let's grab some screws and a motor, and let's go ahead, oh, that's the wrong one. Let's go ahead and mount this up, throw it in the vise, and just see what the flexibility is like with real weight on it. Okay, the first thing I need to do with this is I want to tap these holes. I modeled them with threads in them, but they're 1032 threads, so there's just no way they're going to be sufficient the way they are. So I'm just going to go ahead and run a tap through it. Now, I don't want to cut the material. I'd actually rather just compress it into shape, so I'm actually using a form tap here, and I know doing this in a drill is not the ideal way to do it, but you know what? It's a really fast way to do it. So it's what I'm going to do. And I'm using the bubble level on the back of my drill to make sure that I have this oriented north-south. Now that is hot, and that's probably due to the carbon fiber in here. And I can see I've raised just a little burr around the outside there. Oh yeah, that comes off nice and easy, because after all, it is still plastic material. So I'm trying to think which way this is going to go on the lathe. This way. I'll drop that in. Register's a good fit. I'm feeling basically no movement. And I'm going to put in some 1032 screws. Okay, I had to reset there for a minute to figure out what was going on because the register wasn't sitting in. I was actually compressing it in the vise. So there we go. That feels better. Now let's put in some 1032 screws. And the screws don't feel like they're bottoming particularly well. So this material is probably a little too soft to hold threads, at least threads at this size. So I'm probably going to want to run all the way through this and put a nut on the outside for this application, or maybe 3D print. You know, these are really short. Let me get some longer ones. These screws are too long, but they'll be better than too short. We're just testing today anyway. Oh, that feels much better. Yeah. Screws were just too short. These were ones that were sized originally for going into an 8-inch aluminum plate.
Again, in the mental health community, it's really hard because
see how much flex we've got. Okay, we've got a little bit of flex in that direction, but that's not going to matter much because it's just going to hang like that, and so it's just going to be at whatever angle that is. The real interesting thing is the sideways force on the pulley, because what we'll ultimately be doing is have a timing pulley on here. Oh, we'll use one with the right size hole though.
System is secure.
Yeah, one like that. And then we'll have a belt on it, and that belt will be putting sideways force. So let me just sort of simulate that. That is going to be just fine. There's a tiny little bit of twist there that I can see, but it is not going to be enough. And you know what? If it does, once we get it on the lathe, it's easy enough to make one of these out of aluminum, but I think that's going to work. Well, that is pretty cool. We're going to have to find some other uses for this material around the shop, and I'm sure you'll see that in future videos. I am going to go put this on the lathe. I will do a video about that. I'm not going to do it today. I actually have to pull the backing plate off of the headstock and mill out some clearance to make room for the motor before I can mount this on there. And honestly, that's one of the reasons I've waited so long to do this, because I was waiting to have a full-size mill. In fact, I've got an email in the shop now that will make it a lot easier to do that milling. That's all I've got for you today. If you enjoyed this video, please give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Have you messed around with PACF or any other exotic materials with 3D printing? Leave me a comment below and let me know how it worked. I always learn things by listening to you guys. Thank you for watching.
this idea of what we see.
9:15, I got that one going. I had an issue block.
You've probably seen this new PPA-CF filament from Bamboo Lab popping up on other YouTube channels recently. The specs for this stuff are just wild, so I had to check it out. It's supposed to be stronger and more heat resistant than any other filament I've ever used, so let's do some testing and see how it performs. And if you're wondering why I've got a blast oven here in the shop, this material is called PPA-CF. It's a relatively new release from Bamboo Lab. It's a carbon fiber reinforced nylon material, but it's quite a bit stronger and more heat resistant than other nylons I've used. The technical data sheet quotes its ultimate tensile strength at 168 megapascals. For comparison, that's about double the strength of their PAHT carbon fiber and more than 5 times stronger than PLA, PETG, or ASA. Now that's in the XY direction. In the Z direction, they only claim 57 megapascals, which is quite a bit less, but still well above the strength of most other common 3D printing filaments. Now, in addition to the tensile strength, this material is also more rigid and heat resistant than other materials, so it's supposed to be suitable for high temperature and high humidity applications like under the hood of a car. Now, given all of that, you might expect it to require a special printer, but so far it seems to print just fine in the X1 carbon, and I would expect it to work well in any enclosed printer as long as it's got a 300-degree hot end and a 100-degree heated bed. Now, all this performance does come at a cost, though. Literally. Bamboo Lab sent me this spool for testing, but a 750-gram spool normally sells for about $150 in the US, making it easily the most expensive filament I've ever used. Now, you probably don't want to be printing fidget toys with this stuff, but for automotive parts, that seems pretty reasonable, especially if it means you don't have to prototype parts using other more expensive processes. A couple of months ago, I made a shop-built tensile testing rig. It's based on a standard 6-inch milling machine vise and a 5 kilonewton force gauge. The force transducer and a fixture to hold one end of the specimen are mounted on the fixed jaw of the vise, and a holder for the other end of the specimen is mounted on the movable jaw. I can set the force gauge to peak hold mode and then slowly open the vise to stretch and ultimately break the specimen. When it breaks, the maximum force is displayed on the gauge, and we can divide that by the cross-section area of the sample to determine the ultimate tensile strength. Now, there are a couple of limitations to this setup. Since I'm opening the vise by hand, the rate at which the force ramps up isn't calibrated. The ISO spec calls for a specific ramp rate, but all I can do is try to go as slowly and be as consistent as I can. The second limitation is the update rate of the force gauge. It's only updating once or twice a second, so it's necessary to go slowly to make sure we don't miss the peak value. When I designed the specimens originally, I made them with a cross-section of 7 by 5 millimeters. Now that works great for most materials that I've tested, but if this stuff actually reaches the tensile strength on the data sheet, it'll take almost 6,000 newtons to break the specimens. That's about 600 kilograms or 1,300 pounds. That's more than I can deadlift, and it's more than my force gauge or the grips can handle, so I need to make some narrower specimens. I'll start with a 5 by 5 millimeter specimen, but I suspect that's still going to be on the high side, so I'll prepare a 4 by 3 millimeter version as well, and we'll just see how it goes. I'll print 5 specimens for each test, and I'll print a set of 5 lying down on the bed and a set of 5 standing up. I'm actually not sure whether I'm better off printing the specimens with a thin wall and 100% infill, or printing with 10 perimeters so the extrusions are aligned along the length of the part. To figure that out, and to make sure that my rig is working and calibrated,
I'll run a set of samples in a cheaper material first. This is Bamboo Lab Pet G High Flow. This stuff prints really reliably as long as it's dry, so it should make a good taste. For all of these tests, I'm printing 5 parts, breaking them all, and taking the average. I'm also calculating a 95% confidence interval to try to characterize the variability of the material. It might be tempting to throw out any high or low outlier values, but the ISO spec for tensile testing says clearly that you should not do this. High and low test results should be considered a part of the natural variability of the material or the process. You wouldn't want to throw out the low values if you're testing bolts for a bridge. You'd want to know if some of your bolts are weak.
And make sure you are in
the results from the PET-G testing look very promising. On the left, we have the values specified in the technical data sheet. And you can see that my test values line up very nicely. My 10 perimeter specimens were quite a bit stronger in the XY direction than the 100% fill specimens, but both are within the specified confidence interval.
I hope you enjoyed today's
If you want to split hairs, the 38 megapascal value for the 10 perimeter version is statistically significant, but not enough to be important. With that out of the way, it's time to crack open the good stuff and give it a try. The data sheet says that this filament needs to be dried before use, and it needs to be dried at a pretty high temperature. They call for 100 to 140 degrees Celsius in a blast drying oven. I don't know if you've checked your consumer grade filament dryer recently, but those kinds of temperatures are totally out of reach for that kind of equipment. When Superfast Matt tested this material, he got pretty good results, but the parts looked to me like the filament might have still been a little bit wet, so my plan is to test the filament right out of the package first, then dry it, and see if I can see any differences. When I loaded the filament into the AMS unit on one of my X1 carbons, the printer didn't recognize it. I played with it for a while, I reset the printer a couple times, and then I just gave up and set the material type manually. Now, some of you have probably already figured out what was wrong, so go ahead and write your comment now. It took me a little longer to figure it out. I got halfway down the stairs before I realized the spool might not have an RFID tag in it because it isn't intended to run in the AMS. Checking the website, sure enough, it's not supported in the AMS. For the record, it does load and feed, but the filament is really rigid and I don't know how reliable it would be or how long the AMS would last. So I reloaded the filament in a poly dryer box, connected it up with a piece of PTFE tube, and started the prints. I kind of figured I would need to fiddle with things to get it working well, but it printed great right out of the box. I spent some time looking at the parts under the microscope, and they look great. In fact, they look pretty much perfect. I don't see any signs of moisture, and the print settings look good. The drying tests I had planned might end up being unnecessary, but we'll do them anyway, just to be sure. I decided to start by breaking the vertical samples because I expected them to require less force and therefore they'd be less stressful on the test rig. And those tests went smoothly. But when I got to the horizontal samples, it became clear pretty quickly that my test rig was not prepared for the forces involved. It did hold together, but it took a firm hand on the vise handle, and I could see the 3D printed grips flexing under the load. The grips are printed in PA-HT carbon fiber, which, at least on paper, is quite a bit weaker and more flexible than the PPA-CF I'm testing. Now, some of you probably already have an idea for how to fix this, so go ahead and put that down in the comments. It took me a little longer to figure it out. I'm just kidding. The obvious answer is to print the grips out of PPA-CF, so they'll be as strong as the material that I'm testing. I planned ahead, and I already printed a set just in case, so I can just swap those in. Unfortunately, while your idea was a very good one, it didn't work. This material is much stronger and more rigid than the PA-HT carbon fiber, but it's also more brittle, and one of the grips exploded almost immediately. So I switched back to the PA-HT carbon fiber grips, and I did two things. One, I switched to the 4x3mm specimens to reduce the total force, and I put a couple of can twist clamps on the grips to keep them from spreading. They probably aren't needed, but they won't affect the measurements and they'll provide a little bit of insurance. And here are the results. In the XY direction, we are close to the datasheet value and well above any other material I've ever tested, but in the Z direction, my specimens are quite a bit weaker than expected. They're still stronger than the PET-G high flow and in the ballpark with other lesser filaments, but they're not as strong as they're supposed to be. Let's see what we can do to improve that performance. The first and most obvious thing we can do is to dry the filament. The datasheet says we must, so we will. I do want to compare a consumer-grade dryer to a proper blast drying oven, but I've only got one spool of filament, so we'll start with the consumer dryer. This is an IBOS Cyclops dryer. It goes up to 70 degrees Celsius, and it's done really well for me. I think if you measure the temperature of the filament, you'll find that it doesn't actually hit 70 degrees, but it does get the job done. Every wet spool I've ever put in it has come out dry. Now, it's definitely not capable of reaching the specified temps to dry this filament, but we'll try it anyway. And then, after printing a set of specimens right out of the Cyclops dryer, we'll pop the spool into a proper blast drying oven and dry it at 130 degrees for 12 hours. Now, this oven is designed specifically for drying in a laboratory setting, so it has a PID controller, a heater in the base so that the radiant heat can't reach the contents directly, and a fan to circulate hot air through the oven. It also has an adjustable vent on the top to let out moisture and a secondary safety thermostat that we can set a few degrees higher so that it will shut down if the primary controller fails. I've done some testing up to 300 degrees in this oven with a thermocouple, and this particular oven tends to overshoot by about 0.7 of a degree on initial warm-up, and then settles and holds within 1/10 of a degree for the rest of the drying cycle. That is more than sufficient for what we need here today. Unfortunately, neither of the drying cycles made much difference. Under the microscope, the samples look pretty much the same to me. They're clean, they're smooth, there are no bubbles or other artifacts. This stuff just prints great. And after breaking all of the specimens printed with the different drying procedures, there really isn't much in it. There are some minor differences in the XY values, and the specimens printed after drying actually appear to be a little bit weaker than the ones printed right out of the package. The only statistically significant difference here is the XY value for the blast-dried specimens. For all you stat nerds, that lower value is significant with a p-value of 0.004. There's no significant difference in the Z direction at all. Those values are all within the margin of error. So I think it's safe to say this filament was dry right out of the package, and that was just a big waste of time. You're welcome. The datasheet does suggest annealing the parts after printing to improve their mechanical properties. They suggest annealing at 120 to 140 degrees for 6 to 12 hours. I've got a blast oven right here, so let's try it. It's possible for parts to warp during annealing, but these parts are really simple and they easily lay flat in a stainless tray, so I'll load up a set printed in each direction and run them overnight at 130 degrees to see what happens. Looking at the parts after annealing, I don't really see much difference. They didn't melt, they didn't warp. I think maybe there's a slight difference in the sheen of the surface, but I actually can't decide if it's just a little shinier or a little duller, which means it's probably about the same. Breaking the specimens that I just took so much time and care to bake in my fancy oven, I do see some improvements in the XY direction. We're now up to the value specified in the datasheet. But in the Z direction, we're still not even close. Nothing we've done so far has resulted in any statistically significant differences in the Z direction tensile strength. So now it's time to try some other stuff. Looking through the technical datasheet, they actually tell us how they printed their test specimens. They were printed in an X1 carbon at a chamber temperature of 52 degrees with a nozzle temperature of 290, print speed of 80 millimeters per second, bed temperature of 110, and infill density of 100%. So far I've been able to match all of that except for the chamber temperature. The chamber in the X1 carbon is passively heated by the build plate, and mine never got above 45 degrees. But there are still some things I can tweak. Looking at the broken cross sections under the microscope, I can see that there are still gaps between the extrusions. I can try to close those up in a few ways. I can switch back to 100% infill instead of a whole bunch of perimeters. I can raise the nozzle temperature to try to get the filament to flow together and bond better, and I can increase the flow rate so the printer will try to squeeze more plastic into the same space. I ran a few tests and I did manage to get some improvement, but at 300 degrees and a flow rate of 1.02, the nozzle started scraping off little crumbs of filament, so that's about as far as I think I can take it. Looking at the broken parts under the microscope, it looks like the gaps are pretty much filled in. And as you can see, the improvement is significant. Those changes took us from around 27 megapascals up to 36, and if we anneal the parts after printing, they get all the way up to 37. That's almost a 40% improvement, but we're still falling short of the 57 plus or minus 5 specified in the datasheet. Looking back at the test procedure, the one remaining thing we still haven't replicated is the chamber temperature. It says their tests were run at 52 degrees and that the mechanical properties would be even better at higher temperatures. I had a brief conversation with Superfast Matt about that, and he suggested just trying to insulate the glass top of the printer, since that's likely where most of the heat is escaping. I'm not proud of this. Okay, I'm a little bit proud of this, but I definitely don't recommend that you do it, and I'm not responsible for what happens if you do. But I found a wool blanket and a fire extinguisher, and I wrapped up the printer. Note that there are a few layers of blanket over the top and the sides of the printer, and it's partially wrapped around the front, but the back of the printer is left completely open. The back has ventilation openings for the electronics and the chamber fan, and I suspect very bad things will happen if you block those. To my surprise, the chamber warmed up and stabilized at around 60 degrees, and it printed just fine. I didn't even get to use my fire extinguisher. When I tested the specimens, they broke around 40 megapascals, and just to be thorough, I tried annealing a set overnight, but I didn't see any further increase. 40 megapascals is not the 57 listed in the datasheet, but it's a big improvement over where we started, and it's well above the Z strength of PLA, PETG, or ASA. I had a conversation with my contact at Bamboo Lab, and he reminded me to make sure I have the cooling fans completely off. I thought I did, but I didn't. I still had the switch set to turn the fan on for overhangs, and for some reason, that was causing it to run for the outer perimeters. I turned that off, and that made a dramatic difference. The tensile strength jumped up to 52 plus or minus 7, which finally overlaps the datasheet value. One of the samples even broke at over 62 megapascals, which is why the error bars are wider on that test. But at least I was able to replicate the strength this material is supposed to be able to provide. You're welcome. So what can we take away from the 2 weeks I spent burning through nearly $150 worth of filament and rereading my college stats textbook? Well, first of all, this stuff is freakishly strong, at least in the XY direction. It's weaker in the Z direction, and it takes special care with your settings to maximize it, but it's still significantly stronger than other more common filaments. Second, this stuff is freakishly rigid. Even right off of the spool, it holds the coil shape, and that pushes the PTFE tube and the drag chain around in the printer. Towards the end of the spool, it's even worse. I had to add some zip ties to tie the tube to the drag chain to keep it from getting out of position and breaking the filament while printing. And third, this filament is very heat resistant. I annealed the parts at 135 degrees and saw no visible changes. Other materials would have melted and started to flow at those temperatures. You don't want to pay the price for this stuff unless you need it, but if you need the strength, rigidity, or heat resistance, it may be exactly what you're looking for. If you enjoyed this video or found it useful, give it a thumbs up, feel free to subscribe, and maybe think about supporting the channel over on Patreon. Patrons have been getting a little sneak peek at my early results for this and my other projects in the forums. Thank you for watching.
The very first entry on the top of the screen here is from March 25th at noon. So I was able to start the output from that date. At the time, I didn't know how much. And again, here's the command. is definitely a very useful one to add to your notes. And this might be useful if you are investigating an issue that happened within a particular window of time, so that way you can avoid looking at log entries that are prepared in the event that you're investigating.
Here's the this example. I send it as a gift to another YouTube machinist. They'll make something and send it to someone else, and eventually someone will make something and send it to me. We'll call it. Welcome back to Cloud 42. I'm James, and welcome to Toolroom Takeover 2025. A few months ago, Brandon at Inheritance Machining reached out to me to see if I was interested in a YouTube machinist gift exchange. I said, of course, I'm always happy to help out a smaller creator. There are a bunch of awesome channels involved in this project, including Alex Steele, NBR Works, Blondie Hacks, Jonesy Makes, Not an Engineer, and Eric, with a K, who organized this whole thing. We drew names, and I will be making something for Mike at Cronova Engineering, and I should be receiving something from Uri Tuckman, so stick around to the end of the video to see that. Before this project, I wasn't actually familiar with Cronova Engineering, and when I started watching their videos, I have to admit I panicked a little bit. The stuff they make on the channel is just amazing. Mike's currently making a watch movement entirely from scratch, and he's got another video where he made a miniature steam engine that he had to film with a microscope. If you haven't already, you should definitely check them out. So what do you make for someone like that? I have no idea, so I just decided to make something that I want for myself, a precision taper gauge. I'll make two, and we'll both win. If you haven't used one, a taper gauge is a wedge-shaped tool with a scale on it, but instead of measuring the length, the scale reads out the thickness of the wedge at that point. You slide it into a gap until it stops and read the width of the gap off of the scale. I think it'll be a fun project, and it should give me a chance to use most of the tools in the shop. I'm going to make the taper gauge out of A2 tool steel. I bought it in a 1/4 inch by 3/4 inch flat bar, which should save me a bunch of time because all I have to do is cut it to length, make a nice rounded handle on one end, and then taper it. There are lots of ways to shape the handle end, and I actually dimensioned it so it would be easy to do with a 3/4 inch end mill and a rotary table, but if you've been following the channel, you know I've been converting a Precision Matthews benchtop mill to CNC. There's a whole playlist on the channel if you want to see that, and it's just close enough to done to be usable, which we all know is the most dangerous part of any project. So let's use it. Because the part is longer than the 4-inch vise I have on the machine, I can machine both ends in a single setup. The material's pre-ground, so I won't worry about machining the sides. The material is slightly oversized, but the width doesn't really matter, so I won't bother with it. The end mill I'm using is a 1/4 inch variable flute coated end mill from Lakeshore Carbide. I asked Grok to recommend feeds and speeds for this particular end mill in a PM728 CNC conversion mill, and the numbers it came up with looked pretty plausible, so I just ran them, and they are working beautifully. This is actually the first real machining operation I've done on this machine, post CNC conversion, and so far I'm impressed. It's significantly more rigid than the Grizzly I used to have, and the whole system with the belt-driven spindle and the servos on the ball screws is a lot quieter. I programmed a spring pass, but I really don't think it's needed. All it's really doing is just smearing up the beautiful surface finish I got from the final contour. I had enough material to cut 5 blanks, and I went ahead and CNC machined them all. I need one part for setup, and I want 2 good ones when I'm done, but the cycle time is only a couple of minutes, so machining the other 2 seems like something that a smart person would do. I don't think there's much residual stress in the material, but I don't really know, so I think the safest thing to do is to remove an equal amount of material from each side. If I remove it all from one side, it might turn into a banana while I'm machining it, or later during heat treatment, so I think it's better to just play it
it's safe. I took the taper angle from the Fusion model, and I asked Grok to calculate the correct gauge block stack-ups for my 5-inch sign plate. Half the angle for the first side and the full angle for the second side. I was pretty frustrated with the AI for a while because it kept recommending a stack-up that was too tall and then suggesting that I just subtract 200 thousandths, which is not a thing you can do with gauge blocks. Except that actually it turns out you can. I realized later that my sign plate has a smaller diameter tip on the end of each roll that actually subtracts 200 thousandths, so you can set up lower angles with it. I'm doing the rough milling on a magnetic chuck because it was the only way I could think of to hold the parts and mill the entire surface without machining a sacrificial fixture of some kind. The tip is so thin that I was afraid it would flex if I left it sticking out of the top or the side of the mill vise. The magnetic chuck was just barely secure enough to make this work. It held the parts in place, and it supported the thin tip, but it was definitely sketchy. I did the math and determined that a sharp carbide cutter would have the lowest tool pressure of anything that I had, and there wasn't much difference between a 1/4 inch and a 1/2 inch end mill, so I opted for the bigger cutter just to make the job go faster. Using a roughing end mill was optimistic, even though I packed the parts in on the vise with steel sheet material to try to keep them from sliding around. They really wanted to move, and I had to take lots of light passes on each side, making this easily the most time-consuming part of the project. I think if I had to do this again, I would make some 3D printed sacrificial fences to bear the side loads and allow me to push the cuts harder. You may consider that foreshadowing. Right off the mill, the surface finish looks great, and the parts look pretty straight, at least as far as I can tell. They really didn't move during the milling operation. You can still see the flat facet at the handle end of each part, which means there should be about 15 thousandths of an inch left for grinding after heat treating. I only rough milled 3 of the 5 blanks. I'll keep the other 2 around just in case, but I don't really think it's worth the time at this point because things are going so well. You might also consider that foreshadowing if you like. My heat treating furnace doesn't have a controlled atmosphere, so I have to wrap the parts in stainless steel foil to prevent them from oxidizing. I'll also slip a small piece of paper into each packet. What's written on the paper doesn't matter very much. What's more important is that the paper will burn and consume any oxygen present inside the packet before it gets hot enough to oxidize the steel. I'll also wrap up an extra piece of the same material as a hardness testing sample, so I don't have to make hardness testing divots in the real parts. These all go into the Hotshot 360 oven standing vertically in a ceramic knife rack to try to minimize any forces that might cause them to warp. I did my best to shape the foil packet with a little flat edge on the bottom so they stand up squarely. The oven is programmed to preheat the material slowly in stages before taking it up to 1750 degrees Fahrenheit and holding for 30 minutes. The total cycle is about 5 hours, and then the parts come out of the oven and onto another ceramic rack to cool. A2 tool steel is air quenched, and for thin sections like this, cooling in the foil packet works just fine. It's also way easier and safer than trying to open the hot foil packets. After cooling to room temperature, the test sample measures around 61 Rockwell C, so the heat treatment worked. But the parts are also very brittle in this state, so they go directly into an oven to temper at 260 degrees Celsius for a couple of hours, and then cool slowly to room temperature. After 2 full tempering cycles, the test sample now measures around 57 Rockwell C, which is just about where we want it. That's hard enough to be durable, it's now a lot less brittle, and it should be somewhere close to the peak of the toughness curve for A2. The heat treating is definitely worth it if we want to make a durable tool that will last, but the multiple heating and cooling cycles take a lot of time. It definitely ended up being the most time-consuming part of the project. Inspecting the parts on the surface plate, they all came out bowed less than 9 thousandths of an inch. One of them was only 3 thousandths. That's less than the amount of material we still need to grind off to reach dimensions, so I don't think it's worth trying to straighten them first before grinding. To grind, I'll move the sign plate setup I use for milling over to the grinder. Since the parts are already rough tapered, I only need one angle. I can grind both sides without changing the setup. If you've been following the channel, you know this is a 6x18 manual surface grinder that I converted to CNC. I have a playlist with that video series if you haven't seen it, and just like the CNC mill, it's barely done enough to use, so more videos will be coming as I encounter things I want to do with it. If I just put the warped parts down on the magnetic chuck, the magnet will pull them down flat, which will allow me to make them pretty, but as soon as the magnet releases, they'll just spring back to their warped shape, which isn't what I want. So I need to somehow hold the parts with the bow still in them so I can grind one side flat in the relaxed state. Shimming with brass shim stock only partially works. With the parts frown side down on the chuck and the proper thickness of brass shim under the center, it will hold it at the right height, but the magnet still pulls the part down in places that aren't fully supported, and it just ends up grinding the part into kind of a W shape. And then when I flip it over to grind the other side, this causes the tip to rise up and bite into the wheel. Ask me how I know. So I asked some smart friends and learned about the paper towel trick. If you saturate a strip of paper towel with coolant and put it under the part with the frown side down, it will support the center of the part so the magnet doesn't fully flatten it out. I have no idea why this works, but it does. It holds the part securely, and the grinder makes contact with the middle of the bow first, and it's pretty easy to grind one side of the part flat. And then with one side cleaned up and flat, I can flip it over, placing the now flat side down on the mag chuck and grind directly to dimension. Now, I say that like it's easy, but it's complicated. I only have mist coolant on this grinder, and it is easy to build up heat in the part. The slightest bit of heat in a thin part like this causes it to warp, causes the thin tip to lift up off the chuck and bite into the wheel. The only way I was able to get this to work was to make the coolant mist very, very wet and to go very slowly. For a lot of the finished grinding, I only took 1/10,000th of an inch or even half a tenth or 50 millionths of an inch per pass. With flood coolant, I could probably go faster, but with the setup I have on the machine today, it took a long time to get 3 parts ground flat and 2 dimension. This easily ended up being the most time-consuming part of the project. For my first real grinding project on the machine and my first experience with A2 tool steel, I think it turned out okay. You can see that my setup part has some burn marks from overheating, but the other 2 that I ground more slowly turned out great. There's a little bit of residual warping in the parts, but it's easy to take that out by manually straightening in a copper jaw vise. The first time I tried this, I was afraid the part would snap, but they're pretty tough and springy. You have to push them past their elastic limit to straighten them, and it takes a little bit of practice, but it turns out not to be hard at all. The grinding, of course, left sharp edges, but I can soften those gently with a unitized silicon carbide wheel or a Scotch-Brite wheel. I also did this earlier to deburr after milling, but this pass is just to soften the edges so they feel nice in the hand, being very careful not to haze the nice, pretty, freshly ground surfaces. A silicon carbide impregnated buffing wheel on the NSK pencil grinder easily takes the oxide layer off the rounded edges that I couldn't reach on the buffer. These surfaces are still as is right off the CNC mill, and I actually think they look better than the surfaces that were ground on the surface grinder. One side of the gauge will be marked with millimeters and the other side with inches. I drew the scales in Fusion, and this turned out to be harder than expected. Fusion sketches work great when they're simple, but when you start assembling patterns with hundreds of elements, it bogs down quickly and often crashes while recomputing. This easily ended up being the most time-consuming part of the project. I double-checked the taper by traversing an indicator over the final ground surface using the DRO on the mill to verify that the thickness varies by the correct amount over the length of the scale. I was planning to scale the artwork to account for errors in the grind, but The sign plate did its job, and it was accurate, at least to the limits of what I can measure, and far in excess of what you'll be able to see with your eyes when actually using it. I asked Grok to recommend settings for a 20-watt fiber laser to get a clean, black, slightly recessed mark in heat-treated A2 tool steel. It suggested some settings, I put them into light burn, and what you're seeing is my first and only attempt. The test part looked great, so there's no need to experiment. The laser marking process raises some brown oxides around the cut, and you can see that, but they wipe off easily, leaving a nice, clean engraving. In addition to the scales, I'll also add a Cronova Engineering logo on one side and my logo on the other, and as long as we're here, we might as well mark these as a part of Toolroom Takeover 2025. That should raise their value on the collector's market someday. These are going to the UK, where things actually rust, so I'll give them a coating of BoShield T9, wipe that down, and let it dry. Not only does it prevent rust, but it settles into the oxidized laser and makes the laser markings really pop. I really could not ask for a better end result. This is exactly what I imagined when I was planning the project, but of course, it's always way better when you can hold the finished part in your hand. I'm happy with these, and I would be proud to give them to somebody else, which is, of course, exactly what they're for. It's nice that they're pretty, but they also need to be accurate. Now, I already did some testing off camera just to assuage my crippling anxiety, and to my delight, they're pretty good. Just for fun, though, let's do a blind test. I'll turn off this caliper, set it randomly to some unknown dimension, lock it, and we'll measure it with the taper gauge. Sliding the gauge in until it stops, that looks to me like about 3.35 millimeters. Let's turn on the caliper, and it agrees. I'm really glad that worked. Is this a precision measuring tool? Not really, but also yes. This package has to go across the pond, and I want it to arrive looking exactly like it does now. So I'll wrap it in VCI paper, make a 3D printed case to keep it from cutting its way out of the shipping box, and seal it in a bag with a desiccant pack. I shipped the package using FedEx because I wanted to be really sure it got there in time, and it should have taken 2 days. It's now been 4 weeks. FedEx says they didn't lose it, they intercepted it so that their fraud department could validate my shipper account. That process took 3 days, after which they told me they would release the package, and then they went dark. I have called and spoken to a half a dozen different people in different departments. I have the name, email address, and direct extension of the person who's supposed to be releasing the package. I've left messages, I've sent email, I've even reached out on X and spoken with their social media team. And they all just keep referring me to a number that doesn't return my calls. So I gave up, and I made 2 more. I started with the 2 extra blanks, I milled them, I heat treated them, I ground them, I laser marked them, and that ended up being easily the most time-consuming part of the project. I shipped a new one via the U.S. Postal Service and the Royal Mail, and it was delivered in less than a week with no drama at all. Will the FedEx package show up someday? Maybe. I don't know, but I'll think twice before using them again. In the meantime, I just got a package in the mail from Uri Tuckman, and if you are not familiar with his channel, join the club. I actually had never seen his channel before we did this collaboration, but I have been binging his videos over the last couple of days, and I gotta say, that man is an artist, and I mean that both as a compliment and as a description. The stuff that he makes is just amazing. I think my favorite thing that I've seen that he made was actually a nose-picking machine, and it's something you just have to see to believe. But I got this package from him, and I am really curious to see what he made. Now, it did come with a very nice letter from Deutsche Post that says, following the air freight security and dangerous goods regulations, this parcel has been opened and inspected to determine the presence of forbidden contents. We found it unobjectionable. And I gotta say, if I were Deutsche Post, I would probably open packages from this man too. So, let's see what he said. There's the pigeon. Is this hay? And it smells like alfalfa. Also smells kind of like yerba mate. So, I think that's alfalfa. Did he send a letter? Nope. A piece of hand-drawn art signed by Uri Tuckman himself. There's the upside-down pigeon. Morning Oiler. And if I'm interpreting this correctly, we've got a puddle of oil sitting around an oiler with a brush. Looks almost like a stalk of asparagus, or maybe it's supposed to be covered in oil. That's amazing. Like I said, the man's an artist.
Location 13-20.
Got some oil brushes. And the handle. And yes, that is a stalk of asparagus. Do these fit? They do.
And it's something that needs to be taken care of. I am super proud of my students.
It is amazing. Cloud 42 with the upside down pigeon. Looks like a sandwich with something spilling out. And it is indeed a little oil container. Oh, and this is set up so you can set it like on the edge. Set it on the edge of the desk and it looks like a pool of oil. Oh, this is amazing. That is gorgeous. Well, thank you, Uri. This is amazing. Definitely go check out his videos. This is just a small taste of the kind of stuff that he makes, and this is great. Okay, I just figured it out. It's a fried egg. So it's a fried egg sandwich for breakfast. It's a morning oiler. And looking at the hand-drawn artwork here, it's much more evident. It's an egg. I just didn't catch that the first time. Nice. And that, ladies and gentlemen, is Toolroom Takeover 2025. I'm reminded of a quote that appears often in the Kinetic Precision Discord. We do these things not because they are easy, but because we thought they would be easy. This project was a lot of fun, but it was also way more work than I anticipated, and I learned more than a few things along the way. Now that I think about it, maybe I should add scope creep to my resume. Here's a link to Uri's videos so you can see how he made his gift for me, and here's a link to Cronova Engineering's video so you can see if my package really made it there intact. I'll also put up a link to the entire Toolroom Takeover 2025 playlist so you can watch them all. You really should. Thank you for watching.
It's obviously disgusting. On the plus side, I now know what song I want played at Tom's funeral. I know it'll be hard to get in, but you can throw a Bluetooth speaker pretty far.
So, who's Eric? Eric's the boss. The guy who got us all together for this first Toolroom Takeover. If you haven't heard of it, and you're wondering what this Toolroom Takeover is, we're a bunch of people with machine tools making stuff for each other. And in my case, I drew Eric. So I guess I'm the one in charge of making the boss happy.
Don't mention that I'm a musician.
Eric may look like a young Sid Vicious who got into computer engineering, only to drop out and chase the good life as a machinist. But don't be fooled, he's more Sid than Sid. And when it comes to part-off blades, he's more vicious than vicious. He runs his machine shop from his flat in London, and if hauling tools and machines upstairs wasn't enough, the neighbors gossip about how he's always carrying massive amplifiers up there. Another one goes in, none ever comes in. Those who follow Eric might have heard him say he's a musician, so that's his excuse. And if my job here is to make him happy, then I guess there's only one thing I can build. An amplifier. I'll need a transformer, a turret board, an output transformer to drive an external speaker, and since we're already committed, let's add a built-in speaker too. After all, I'm not the kind of guy who sends things out incomplete. I also need to include a machine component. That's rule number 1 for this club. Yes, nerd knobs are cool, but what I really want to make is a custom power switch. Now, as you know, metal is conductive, and killing Eric is something I'd like to avoid. So my power switch can be switching mains power, at least not directly. I need to convert mains power down to 5 volts for the switch, which makes it safe to touch, and then use a relay to actually switch the mains. The only problem is, I know nothing about the electronics, but I'm still gonna tell you exactly how I pull this off.
which will improve the performance.
I started by ordering some PCB blanks. I thought I could laser engrave them, but then I learned FR4 boards are made of fiberglass, and fiberglass melts under laser heat, or at least that's what the internet will tell you. What I basically needed was a way to convert mains voltage to 5 volts, and then, with a 5 volt signal, trigger a 10 amp relay. That's something you can do using a couple off-the-shelf modules, cheap and ready to go, straight from China. All it takes is a couple of wires to hook them together. So, I copied them. I looked at the components, figured out what they were doing, and tailored the design for my build. Then I tested the main circuit on a breadboard, and it worked, mostly. After some fine-tuning, I was ready to design my first PCB. Learning KiCad led me into my latest love-hate relationship, but I was determined to continue, even knowing full well each click was as unpredictable as my micrometer. After I dropped it. The boards I received were obviously bent, so I used these clamps to make sure they sat flat on the laser pad. Fixturing them properly also made sure they'd return to the same place every time. I tried a bunch of laser settings until I found a sequence of passes that didn't burn the fiberglass. And before you ask, let me ask you, where do you get your FR1 boards from? It's just a 20 watt laser, so it takes a while to get there. Meanwhile, as I checked the pads for continuity, the Bamboo Lab was already printing parts for the next step, the solder mask. Here's a microscope view of what you can expect from this process. The traces look well defined, and there's no sign of copper left in unexpected places. I've never done anything like this before, so if I'm missing something, let me know. I decided to go with 2.5mm traces for the AC section, which I'm separating from DC before applying the solder mask. These physical gaps increase both clearance and creepage distance, which is important when you have AC and DC sharing the same board. Basically, the slots make it harder for electricity to jump across and cause a short. Additionally, I made sure there's at least 6mm between AC and DC traces. The relay pins are obviously a limitation. I can't change those, but that's why I added a slot around them. The DC traces are 1.5mm wide and the circuit is rated for 600 milliamps. Actually, if you subscribe, I'll do the right thing and add a 500 fuse. The traces are probably bigger than necessary, but that's what you do when you're not confident in what you're doing. Applying solder mask evenly on a board this size wasn't as easy as I thought, so after curing, I resorted to methods I know well. Yup, sanding. Just a thought, to make it flat. After laser engraving the silkscreen layer, I flipped the board to do the solder pads. This required tweaking the laser settings a little bit, but in the end, I managed to remove just the solder mask without ablating the copper. And now, the real reason I wanted the top layer flat. This was the hardest part of the process for me, and probably unnecessary, but if you get it right, it looks beautiful. Finally, I cut the board using settings that were probably too aggressive, and got ready to drill holes for the components. But Eric texted me. He asked if I could use my fiber laser to create scaled-down versions of Queenswell signs, the round logo in aluminum and the yellow, the safety sign, in brass. I can do it, but I want to help Eric, but there's no way I'm replicating that ball sign in brass. From what I can tell, the original is painted sheet steel, with stenciled lettering, pretty much like these old garage signs. I love this kind of stuff, so let's try to do it justice. Given the size, I think a vinyl cutter would be the way to go, but I don't know anyone who has one. However, I do have a 3D printer. Yeah, finally.
There is still a slight delay, but it's less.
Yeah, this was the third one I made. The first didn't turn out the way I wanted, so I made a second. But that one was just as bad, so here we are. And this one isn't perfect either, but I don't have time to make another. I really need to get back to the PCB.
Now, if you do decide to purchase a hotspot and you're in the USA,
but first, one last detail.
Get yours from not just because of the amount of storage options and primary
for business cards. But did you know we print everything you need to get your brand in front of your fans? We've got banners and signs that help your business stand out. We've got postcards and flyers that get people talking. We print must-have merch, paper bags, t-shirts, and water bottles. Whether you want a few or a few thousand, we print on everything so that customers can go from noticing your brand.
I wish the letters were better. The problem was, when I removed the tape, the stencil moved. And I had to take it off while the paint was still wet, because my other two attempts failed for that reason. I was letting the black dry, and the yellow paint chipped when I lifted the stencil. Anyway, I hope Quinn likes it. Eric's waiting, so I'll get this packed for shipping. Oh, by the way, you'll never guess who's gonna send me some Yandees. So, since the beginning of this project, I had this idea of making a switch with the code. 4 wheels with 26 letters each. When Eric's name aligns at the top, the M turns on. Any other combination keeps it off. Pretty simple. All I had to figure out was how to get that click feel for each letter,
had to be the cutting board. When I got home, I checked
how to make the electrical connection happen, and how to keep it isolated from the wheels and posts. Even though it's only switching 5 volts, the switch should always be isolated. I spent some time in CAD trying to come up with a solution. That usually helps, but this time it didn't. Total creative block. That's why I started with the PCB first. I tried to buy some time, hoping the switch would figure itself out. Soldering components to a board was also a first for me, but when you have friends who support what you do, and if needed can lay out complex concepts in a way that makes you think, hey, I totally got this, life gets better, and your dreams start to feel tangible.
There's really only 2 things you need to know about electronics. The first is they should be avoided at all costs.
Getting the MMR vaccine isn't just
Starting
important
JSON
for
security
scan.
But if you can't manage that, number 2
Emily, thank you for that.
is that the smoke needs to stay inside.
Look at how ICE operations played out today.
Thanks, man. Solid advice.
Our cameras there as arrests were made and officers of
This Euro-type M&M can absorb voltage spikes that may come from the AMPS transformer, especially when the relay turns off. We don't want those spikes making their way to the relay because they can cause arcing across the contacts, and that's guaranteed to wear them out faster. But the varistor is not alone. I've also got a resistor and capacitor in series, and that's called a snubber. It helps smooth out the switching and cut down on electrical noise. I'm pretty sure the relay is gonna flicker sometimes, because custom switch, so I'm just trying to keep this whole thing from self-destructing. So one by one, my board began to fill with colorful components. And if a little bit of solder is good, then a little more must be better. That's when I realized what PCB really stands for. Potentially cooked board. As soon as I could test the DC part of the circuit, I did. I didn't find anything strange, but you probably did. Like this fan or the lighting connection. None of that makes sense on an amplifier, but we'll get to that later. The AC to DC transformer was added afterwards, and then I left the board running for a few hours. I checked the temperature from time to time, and nothing was heating up. Actually, the whole board was pretty cool, but right as I was finishing up testing, I found this problem. If you didn't catch it, after unplugging the circuit from the wall, the board can still be turned on for a few seconds, and then it dies by itself. Now the problem is obvious, it's a charged capacitor, but I thought it was the filtering cap I have after the transformer. After testing, it turns out the problem was actually the transformer, which is a closed box. I was still measuring 5 volts for several seconds right on the transformer's output legs. That's even before my capacitor. So to fix this, I tried adding a few different resistors across that cap. A bleeder resistor basically helps drain the capacitor faster, but it does use a bit of power, though in this case it's probably nothing to worry about. But since I didn't want to make a whole new board, I just soldered it on the back. That seemed to work for the most part. It's not perfect, but I managed to shrink the window to reproduce the problem down to about 1 second, or pretty close to that. And with that done, it was time to put the PCB away. As for the switch, I still had no clue how it was actually going to work. I was stuck with this idea of a tooth catching a groove on the back of the wheels for that satisfying click. But no matter how I pictured it, it always seemed awkward to machine and tricky to adjust. It just didn't feel right. But without a better idea, I figured I just needed to start. So I started, by breaking a chamfering tool. Then I broke another one. The third wasn't a charm, and his end mill snapped when I told it what happened to his chamfering friends. Yeah, I'm pretty sure Brandon jinxed me. So if my plan of not having a plan wasn't working, all I had to do was change the plan. And just to be safe, avoid chamfering tools. Now let's stop messing around and get down to business. I only need 4 rings, but I'll cut a few extra, because if you got spares, you'll get it right the first time. So I clean all these parts with brake cleaner. This is stainless, 303, but it's incredible how isopropyl alcohol still managed to clean them even more. Ideally, I'd like to passivate everything, but I'm not sure if I'll have the time. Sometimes stainless rusts because of these tiny particles left over from the turning process. I wanted to make an amplifier because I thought it was cool. I'm talking about a tube amp, not solid state. First, I saw these DIY kits for sale, but everything escalated very quickly when I tried to confirm if they'd work for bass. I don't know if I mentioned that, Eric plays bass, just like Steve.
Scan complete.
Didn't.
System is secure.
Turns out those kits are a joke. I mean, technically they make sound, but so does the microwave. After weeks of searching for a bass amp that was simple enough for me to build, I couldn't find a single one. So I did the sensible thing and decided to design my own. Now, in my defense, I had no idea about the rabbit hole I was getting into, but this was actually how the project started. One of the downsides of having a small mill like mine is the lack of rigidity. In this case, the issue might not have been the mill alone, but I was consistently getting a taper after each pass with the boring head. So before I went oversized, I decided to take it to the left. I bought this reamer specifically to help me finish this part faster. Just like what happened with the boring head, small boring bars tend to flex on deeper holes and produce a taper. So investing in a reamer seemed like the best way to get the hole on size. Well, not if it cuts 0.3 millimeters oversized. This might seem confusing. I mean, why go through the trouble of drilling a hole just to press fit another chunk of steel? Simple. Stainless is harder than mild steel, and it doesn't rust. And when I realized I started rounding the wrong side of the part, except I was wrong. It was the right side after all. There are 5 parts in this block. You just haven't seen them yet. Like this arbor from my slitting saw. Didn't see it until I had to make it last night. As for my take on the base ham, eventually I came up with a schematic, and I can't count how many people I bothered with it. I asked for help anywhere I thought I might get it, but there wasn't much feedback. Apparently, the words newbie and 400 volts don't make a very compelling pitch. Then, my mill decided to start making new noises. But unless it's the bearings, there's no way I'm stopping the show now.
Does the object in this photo look familiar to you? Possibly take you back to college physics class. Dr. John Shive, host of this next film, invented it at Bell Labs in the 1950s. It's called the Shive Wave Generator. Shive...
Show it, George.
I'm no stranger to persistence, and I don't quit easily.
The best drivers will already be stored, but here for open video, we'll just...
2917.
By this time, I had refined my schematic to the point where people started telling me I should just build it, test it, and then start fine-tuning it. That was when I realized I'd actually need to tweak components until the amp sounded good. I wasn't expecting that. I thought I could come up with something on paper that was close enough to work on the first try, but that was a real problem. For one, I don't have a bass. I don't know how to play, and even if I had someone to help, which I don't, I wouldn't even know what sounds good or not. My hearing's just not trained for that. Not to mention time, I don't have much left, so that blind optimism I had at the start, it had now shifted into the worst kind of anxious pessimism. I spent countless hours trying to figure this out. One of the people who helped me was Mikko from Uraltone in Finland. I can't thank him enough. In the end, he brought me back to earth and convinced me to do the reasonable thing. Build something tried and tested. A Fender Champ replica, the classic 5F1 amp. It's basically the starter kit for anyone getting into amp building. The only catch is, it's a guitar amp. Now, Eric plays bass, but I've seen the guitar in one of his videos. So, sorry Eric, seems like you'll have to change roles in your band. Honestly, it was my only way out. So I ordered the parts from Eurotone and jumped back to the Switch. Speaking of which, I still had no idea how to make the wheels click. I just had a vision of the amp finished, and in my head, it looked beautiful. So let me share the new layout. You're looking from the top. The PCB I made goes at the back and connects to the turret board in front of it. The power transformer goes on the left, with the output transformer at 90 degrees. That's to minimize electromagnetic interference. Then, and I know it's unconventional, but the speaker will point out, far from the power transformer. The tubes go in between. The tubes are actually the cool part in this, so I want to add a square window so you can see them. Clear acrylic. Needs to be seamless, but access to swap the tubes also needs to be easy. Everything will be on a steel chassis, probably clear coated. I want the chassis to have this dull finish. The frame or cabinet will be plywood, 18mm. Rounded corners mean I need to learn how to make curve cuts, so I can bend the board to form a square. The good part is, since there's a window for the tubes, there won't be any seam to hide. For the sides, I have this roll of walnut veneer left over from something else. It's very thin, and I don't have much. I need to test it first to see if it works. The top will have two separate pieces. The speaker side will be wood covered with this grill cloth, typical of Fender amps, and the electronic side will remain visible. I still need to confirm, but I'm pretty sure I have a friend who can cut and engrave some acrylic for me. All the switches will go on the acrylic piece, except probably the power switch, which is too heavy. For that one, I still need to figure out what to do. Some acrylic posts would be nice, to make it look like it's floating, but I don't know yet. Finally, the amp will probably get hot, so I'll add ventilation holes where it makes sense. And I'll have this fan underneath the tubes and the power transformer. It's a 12-volt fan that will run at 5 volts. It's dead silent and still moves some air. The only thing I don't like is the weight. It won't be balanced since all the weight is on the left. But this is like a record player. You're not supposed to move it around much. Oh, and finally, I bought these. €1 each. I still need to slice them into fine strips, but they'll be useful to hide the plywood edges. Think of edge banding, but one that can be sanded and matched to the sides. There are still some things to figure out, but everything has its place for now. And the reason I wanted my PCB to support some LEDs is because the interior will be illuminated. That should be obvious now. What's also obvious is that I need a guitar to test the amp. I borrowed this one, but it didn't work. Then I got this other one, but it also didn't work. I traced it down to a bed pot and already ordered a replacement. These side projects just don't seem to end. Meanwhile, I got these ready. I didn't really know where I was going with it, but they say things happen for a reason, and these must be one of those cases. I stopped for a moment and went outside. Needed to recharge my batteries for 5 minutes and get some fresh air. I was about to head back when I saw something. Dirty windows. But there was something else. A pigeon? I could tell immediately there was something strange with it. The way it moved, the way it was trying to open its little beak, I could feel it was trying to tell me something. I was perplexed. And then I heard the words I was so afraid to hear. Stop wasting your time and get back to work. I said, sure honey, and went back inside. But I couldn't shake that feeling. What was that little creature trying to tell me? What could it possibly be? And then, all of a sudden, it came to me in a flash. And I knew what I had to do. The center was already dead, and like all things dead, it was bound to turn into something else. 13 was the number I was looking for, and a custom plate is a plate I can't make, because to make it, I'd need a 13, and 13 was the number I was looking for. And then I heard the man, the pigeon man, the man with answers about time, life, death, and hope. He only said 2 words, and it was not get back to work. 3 turns, 1 hole, 13 on the plate. The pigeon man said luck had nothing to do with it. Crank that handle if you can handle it. Albrecht's a German company, and this drill is way too small. If you're not ready for what's coming, click subscribe. Even the pigeon knew when to fly. One day you'll turn 40 and on that day, you'll realize the ratio had been wrong all along. Add 50 to make 90. The Z-axis motor would be nice. 3 turns, 6 holes. The 13 came to stay. And luck? Didn't I tell you it had nothing to do with it?
You say, how did we find out about this? Well, it only came to light when a protester was arrested by cops, and they only were able to track the two images and the actual judge threw the case out, citing it. But wait a minute, what if cops no longer have their Which leads perhaps the biggest loophole of all, surveillance.
Oh pigeon, save us from broken drills, taps, chamfering tools and the wandering rimmer. Eric's with a K, like knurling, or a key to a door that opens into this tool room. Come take over. Come if you dare, but bring your own calipers. My mic's as dead as that center, and I'm waiting on a new one from KBC, with a K, like Eric. Tomorrow I'll machine stainless. I want to use a ball and mill. So before I decided to use a ball end mill, I also tested the spot drill and the regular end mill. The spot drill didn't really work, it made the wheel feel too sloppy, I didn't like it. But the end mill actually worked really well. The ball end mill just feels right, so that's the one. Yeah, so this will be adjustable, and it's how the letters will snap into place. It's just a spring and a 4mm ball, basic detent. Oh, and the stuff I bought from Uraltone's already here too. The transformer is way heavier than I thought. The tubes are beautiful, I really like them. The speaker is a 6-inch, I know it's small, but this has to be a small amp. Going up to 8 inches would have made the cabinet a lot bigger, so I went with 6. Miko recommended this one, so yeah, can't wait to build this. What also came was my micrometer from KBC. KBC has been helping the channel from time to time with some tools, which I highly appreciate. But they have something for you as well, as this year they turned 60. In the description, there's a nice discount code for you. Thanks, KBC.
Copy of Windows 7 running.
Now, 2 steps forward, 1 step back. I thought I had someone who could cut and engrave the acrylic for me. Yeah, forget it, that's not happening. No more access to the CO2 machine. I had a quote from a company, and it's just too expensive. So that's another thing to figure out, how to make the top in acrylic.
T-shirts and water bottles. Whether you want a few or a few thousand, we print on everything so that customers can go from noticing your brand to falling in love with it. Right now.
That on the informant.
Come on, man, we'll make it high and tight. Let my people go.
So the real question is whether
these were definitely the smallest parts I've ever turned.
Even if that means earning a
what I did next was stupid, but I had to try it anyway. Each post has a Delrin bushing to isolate the copper contact. These contacts are already pressed in, but I didn't solder the wires for the 2 outer posts. Delrin melts at 170 degrees Celsius, so no way it was going to survive the soldering. So what follows is me trying to save these parts. Basically what was missing to make this a true DIY project. And the problem is not even remaking the parts, it's the fact that I only have this copper left.
The truck just on the, there's a truck on the roadway, it was the juvenile that was black on black.
Charlie 42 copy, Paul Lincoln 0284.
To reface the contact surface, I took advantage of the threaded bushing and faced it on the light. Actually, this was only for one of the posts. Only the first one is threaded. For the second, I had to make an extra threaded bushing, press it in just to reface the surface, and then change it again for a plain bushing. Meanwhile, I already had the base machine and ready for a dry build. But I also had one foot in the amp build. I wanted to have a dry build first since I wanted to deal with all the problems at this stage, not after everything is integrated into the cabinet. Testing is a big deal when you're creating something from scratch. Sometimes individual components seem fine, but problems show up when they're integrated with others. So with the switch ready, I decided to try it out and run a little integration test. I wasn't expecting anything to fail, the switch was working well and so was the PCB, but this time I decided to add an AC load to actually activate something with the switch. I had this tiny drill press at hand, so I didn't look any further. And what happened was this. I was puzzled. How is this able to pulse, with one disconnected wire, and how is it possible to have 80 volts coming out of the relay? It's off. Remember when I said I knew nothing about electronics? Really felt it here. After reading a few things, I swapped the drill press for a light bulb, and with the light bulb, it worked as expected. The 80 volts, when the relay is off, were now less than 1 volt. So what's happening? And does this represent a problem for the amp? I came across something that might be the reason, but I'm not entirely sure. The drill press has an AC to DC adapter, which might have high output impedance, and it's not syncing the ghost voltage from the PCB. The bulb, on the other hand, acts as a resistor and drops the voltage. So this might be all ghost voltage, not real voltage. And the motor? That, again, might be due to some energy stored internally in the adapter, and the fact that I'm not disconnecting both wires. But will these affect the amp? The internet says so. Looks like it's a real problem. But I don't really get it, because the original switch for this type of amp also disconnects one wire only. Remember electronics first rule? Yeah, that's right. Avoid at all costs. To fix this, there were these two options. Budge it one more time with a bleeder resistor across the AC output terminals, that simulates a light bulb, or change to a double pole relay. With this relay, both AC wires get switched on and off at the same time. Going with the first option would mean my third budge on this board. And while I'm okay doing that kind of stuff on the DC part, on the AC, I'm not so comfortable. It doesn't feel right, especially when it's a gift from somebody else. So I've chosen to make a new board, integrate the resistors on the back, change to a DPST relay, and somehow stop this flicker on the relay. That's enough. So I turned to Eric and asked for more time. I still had the amp to finish and the entire cabinet to make. Eric's a great guy, so he said, "Absolutely no." I was exhausted. I called for the pigeon man, but he had already flown. My muse was gone. All I could do at this point was cut down on stuff. I simplified the cabinet until it was just 6 boards. I threw the code switch in the bin, no need for the PCB anymore, but then I was breaking rule number 1, so I went back for the switch. We had a good 4-letter talk. Love, hate, fear, pain, hope, rage, loss. This project had failed after all. Grief. I miscalculated how long it would take to build the amp. Maybe my dreams were too big. I left no room for setbacks and I had too many along the way. And now there's no time to finish the amplifier for Eric. I went to bed devastated that day. But the next morning, I woke up feeling... Oh, wow. Wow, it's beautiful. I kinda knew what it was. Customs? You ruined this for us. But I had no idea what it looked like. It's beautiful. I love the steel logo. Thank you so much, Alec. Now the question is, does it fit? So Alec made me a gear knob for my Mini. Unfortunately, this car has been sitting still for the past 5 years. The word on the street is that I even started a YouTube channel just to avoid finishing the car. Can you believe it? The audacity. Anyway, I can't show the knob in this Mini right now because it doesn't have the engine. It's rebuilt, just not in the car. So what I can do, just this once, is showing the knob in my other Mini. By the way, did you notice knobs with a K? Just like Eric? Are you connecting the dots? Well, it does the job. I was trying to figure out how Alec made this. And obviously this was forged, but the question is how? Alec's been playing a lot lately with 3D prints and some PLA patterns, and then this was laser engraved. And I thought this was brass, but I just talked with Alec,
and this isn't brass.
That's right.
This is 24 karat gold. So I'll leave you with that piece of information and a thought. Next video, making a vault with a 4-letter code. Until then, click here to watch Alex making these, or here to watch Eric opening 10% of an amplifier. See ya!
Graphics, the best drivers will already be installed. But here for NVIDIA, we'll just
It is still a first draft. The applications are very settings of area whereabouts. At this time, you clearly see that some stuff is not animated as it should be. Some stuff is not smooth as it should be. There are some performance problems with moving and closing apps or short keys.